When I type ls-lh, we see the files and directories in this directory, and up to now I haven't really said much about the first, third, and fourth columns that we see here. In this video, we're going to look at what they are and why they're important. We're going to start with the third column. The third column is the user owner of the file or directory on the right. You'll see why I'm calling this the user owner in a moment or two. The fourth column is the group associated with the file or directory. Every file and directory must have a user owner and a group assigned to it. When I type ID or ID Michael, we see the user ID for Michael and the group ID for Michael, and then all the groups the user ID Michael is a member of. And notice they all have a number with the name. Linux uses the numbers. The user ID name and the group name, they're there just to help us humans know that user ID 1000 is for Michael and group ID 1000 is the group for Michael. A few videos back, we deleted a user but kept the files. Since the user ID was gone, there was no name to display as the user owner or the group. So all we saw was the user owner number and the group number. So files and directories must have a user owner and a group. Now that we know what columns 3 and 4 are, let's look at the first column. And I think we discussed this first character of that first column in an earlier tutorial in this series. That tells us what type of file it is. If we have a D, it's for a directory. If we have a dash or a hyphen, it's for a file. And we've also seen the L for a symlink. There are a few others, but those are the three most common. The rest of this first column are the file permissions. Let's look at the permissions for the documents directory. The permissions column is broken up into 4 sections. The first section we just talked about, and that's that first character that tells us the file type. The next section tells us the permissions of the user owner from column 3. And we see these permissions are R for read, W for write, and X for execute. And they use an X instead of an E for execute. So the user owner has read, write, and execute permissions. The third section is the group permissions. If you're not the user owner of the file from column 3, but you are a member of that group from column 4, you have read permissions, and instead of write permissions, you've got a dash, meaning group members cannot write to this file, but they do have execute permissions. The fourth section are the permissions for anyone who is not the user owner of the file. They're not in the group, but they do have access to this file. And in this case, those permissions are the same permissions as the group. They can read the files, they cannot write the files, but they can execute a file. In this case, we're looking at a directory. And just because the directory permissions says they have access to read and execute, doesn't mean they can read and execute every file in that directory. The permissions for a file or directory in that directory have a priority over the directory permissions. When I say that, I mean if there's a file in that directory that has all dashes for the group and other, those no access dashes will override the folder directory permissions. Group and other will not have any access to that file or directory. Although they'll be able to see the file name or the directory name, they will not be able to do anything with that file or directory. A file owner can change or modify the permissions of their files with the chmod command. Chmod is for change mode of a file. I'm going to change the permissions for the nanofile.txt file, and to do that, I will type chmod for change mode, and I want to change the user owner to have read, write, execute privileges. So I will type U for user owner, then equals to assign the permissions of read, write, execute. Now I'm going to place a comma to separate things, and then I'll put a G for group, and I'll put an equal sign to assign the permissions of read and execute. Notice I did not place a dash or a hyphen in there, just the R for read and X for execute. And now another comma. And I will give the other permissions of read only. So O equals R. Then I will add a space and the file name I want to change, which in this case is nanofile.txt. Pressing enter and ls-lh shows us that the nanofile.txt file permissions have been updated. Here you can see why I've been referring to the file owner as the user owner throughout this video. Because when you update the file permissions this way, O is for other and U is for user owner. If we want to give everyone the same permissions like read only, I can type chmod UGO for user, group, and other, and then the equal sign. That will set their permissions equal to what I place after the equal sign. In this case, it's an R. Then our space and the file name, nanofile.txt. Pressing enter and ls-lh shows the permissions are set for user, group, and other to only have read privileges. Instead of the equal sign, we can use a plus sign to add permissions. Let's say that I want to add execute permissions for the user owner, the group, and other. I can do that by typing chmod U for user, G for group, O for other, plus to add the permission of execute. And because I have user, group, and other, instead of typing UGO, I can use an A. So now I'm using A for all, and I'm adding the execute privilege, and I want to do that for the nanofile.txt. And ls-lh shows us that now we have read and execute privileges for everyone for the nanofile.txt file. We can also take away permissions with the minus sign, and we can do multiple changes in a single command. I will add write permissions for the user owner and take away the read and write permissions for the group and other with the command chmod U for user, and I'm going to add the write permissions with plus W, then the comma, and then G for group, O for other, and I'm going to take away the read execute permissions with minus RX. And this is for the nanofile.txt. And notice there's no space around the comma. When we do multiple changes at a time, there's no space between the changes, just a comma. And ls-lh shows that we've added the write permission for the user owner and taken away the read execute permissions for the group and other. If we're changing the permissions for a directory and we want the same permissions to be applied for every file and directory in that directory, we would need to add the uppercase R option for recursive. I'll type chmod uppercase R for recursively apply these permissions. We'll give the user owner read, write, and execute permissions. The group permissions will be read and execute. And then for everyone else, we will give them read permissions. I will give this the directory name, new directory. And typing ls-lh shows us that the new directory permissions are now set that way. Setting the privileges this way is called alphabetic notation or symbolic notation. They're the same thing depending on who you're talking to. It is when we can see the letters or the symbols. The other notation for setting privileges is called octal notation. We still use the same read, write, and execute for user owner, group, and other, but we use a single number to set the user owner privileges, a different number to set the group privileges, and a third number for the privileges of other. How this works is read, write, and execute each have a value assigned to them. Read has a value of 4, write has a value of 2, and execute has a value of 1. And then no privileges has a value of 0. If we add these up, 4 plus 2 plus 1, we get 7, the highest number we can have. But we can also use 0. So we have 8 different numbers we can use for the permissions, and that's where we get the name octal permissions. Let's look at an example. In this case, the user owner has read, write, and execute privileges. So we have 4 plus 2 plus 1, and we get 7. So the user owner octal privileges is 7. The group privileges are read and execute. 4 plus 1 gives us the octal number of 5. And the other only has read privileges, so their octal number is 4. Then we take that same chmod to change mode of the user privileges with those 3 numbers. Chmod 754 nanofile.txt ls-lh. And we see we updated the privileges using the octal notation this time. If we want to give the user owner full privileges and no privileges for the group or other, I would chmod the file permissions to be 700. And I'll do that with chmod 700 nanofile.txt ls-lh. And now only the user owner has privileges for this file. If you are working on a website or something connected to the internet, it's usually a bad idea to give the privileges of 777. Although you may need to at times, at least temporarily, you should still be careful when and where you do that. If you have a website with 777 privileges available to the general public, you are inviting hackers not only to add malicious code, but also they can execute that malicious code. In general, if you want the public to have write access to a directory, that's okay, but don't give them execute access for that same directory. And the same thing for the execute privileges. If you want the general public to be able to execute files, that's okay too. Just don't give them write privileges for that same directory. In the next tutorial, we'll continue looking at the Linux command line.